Okay, good afternoon again. Proceed tayo sa last topic ng SEM. So this is the sinusoidal steady state resonance. Okay, nakita natin last time na for RL and RC circuits, meron tayong sinusoidal steady state. So nag-modify tayo ng paraan ng pagsosolve ng mga bagay-bagay kapag binigyan tayo ng isang circuit na may capacitors or inductors tapos may input na sinusoid. Okay? Okay. Napansin nyo, ano pa ba napansin natin last time? Balikan nga natin. Ano ba nakuha natin last time? Ayan, meron tayo nakuha mga low pass and high pass filters. Tapos nag-graph tayo. And then frequency response. Okay, so may impedance tayo. Ano ba? Okay. Bansin natin for an input na sinusoid, yung response din ng system natin, sinusoid. Okay? So for every, sa capacitor, may sinusoid ka, and so on and so forth. Now, one would think na kapag dinagdagan mo, no, nag-capacitor and inductor ka ng sabay, kakaroon ng dalawang sinusoid. And sometimes, yung waveforms nila nagsasabay. So they would interfere with each other, magkakaroon ng interference na constructive or sometimes destructive. And kapag constructive sila, meron tayong tinatawag na resonance. Okay, parang sa music lang. May mga beats tayo. Naalala niyo ba yung mga beat frequency, ganun? Kuwari, nagpatugtog ka sa piano ng C, tapos nagpatugtog ka rin ng isa pang note na one octave higher. So, kuwari, pinindot mo C3, tapos pinindot mo C4, magkakaroon ka ng resonance between those two. Mas maganda yung tunog. Okay? So, parang ganun din dito. Pag meron tayong capacitor, inductor, meron nangyayaring resonance. Okay? So, last time, puro RL and RC lang tayo. So, this time, RLC na. Okay? Okay. So, let's try this circuit. Meron tayong parallel RLC. Input natin ay current na cosine tone burst. Ayan. And we're trying to get V here. Okay? V here. Okay, syempre, yung gusto natin makuha, yung complete response muna. Try muna natin kuhanin yung complete response para naman maayos buhay natin. Huwag muna tayo mag-frequency response, yung mga nag-approximate lang tayo ng mga bagay-bagay. Okay? So, yan. As usual, differential equations, then homogeneous, particular, tapos yun na. Okay. Binigyan ka ng problem, huwag magpapanik. Lagyan mo muna ng KCL or KVL. So, tingin natin, mas madali dito yung KCL, no? Pare-pares to ng voltage. Okay, KCL tayo. So, at this point, yung incoming mo ay yung I of t. Then, yung outgoing mo, yung tatlong ito. Okay? So, therefore, I of t on the left-hand side, incoming. And then, inductor current, let's call that IL. Plus, yung current sa capacitor is just V minus ground. So, V over R. V minus 0 over R. So, that's V over R. And then, the capacitor, yung current sa capacitor ay IC. But yung IC natin, pwede natin siya isulat in terms of the state equation, which is C dV over dt. Okay? Okay. We can further generalize this para isang variable lang na meron tayo, which is yung V. Okay? So yung IL, di ba, pwede mo siyang i-derivative para makuha yung voltage. So in that sense, let's derivative everything. DIT, T, tapos multiply ako ng L both sides. plus LV over R. Ay, naka-derivative nga pala. L over R, dv over dt. And then plus LC d squared v dt squared. Okay. Okay. Now, this is just voltage. So, LDI. This is just voltage. Okay, then, ayan na. Simplify mo na lang na mas maayos. You end up with this. Ay, wala palang L dito. Okay? So, this whole thing is just yung inductor voltage, which is just V, kasi lahat sila ay V. Okay? So, with this, divide mo na lang ng mga constant para it looks nice. Then, you would obtain this part. Okay? Okay. So, divided by LC lang everything. Okay? So, over LC ito, mawawala na dito. Tapos, 1 over RC lang dito. Then, 1 over C sa kabila. So, 1 over C, 1 over RC, 1 over LC. Okay? Okay. Straightforward pa naman, walang bago, walang anything. Okay? And then, homogeneous and ano tayo? Particular. So, for the homogeneous part, zero out mo to. Walang input. Kunyari. Okay? So, dv dt plus v over LC. Okay. And then, as usual, yung ansatz natin for the homogeneous part is tawagin natin VH na. VH ay A e raised to ST. Okay. So, let's do this. Plug in natin dito. So, equation natin would look like this. Derivative, dalawang beses, babagsak si S. So, meron akong S squared. As is pa rin yung function natin. Then, derivative here once, bababa ng isang beses yung S. Then, may RC ako. Same function pa rin. And then, I have here 1 over LC plus the function, times the function, I mean. Okay, and then cancel dahil divide by this factor. I-absorb lang ng 0. So therefore, you have this S. Nasolve na natin si S na. Plus 1 over LC or 0. Okay? And then as usual, as before, let's call this 2 alpha S plus omega naught squared. Okay, para kit lang. So this one here is omega naught squared. So that's omega naught equal to 1 over LC. Then yung 1 over R is equal siya sa 2 alpha. Okay, so 2 alpha is equal to 1 over RC. Tapos, solving for S, you have two solutions for this. You have negative alpha plus or minus square root ng square root ng alpha squared minus omega naught squared. Okay? So, ganito yung usual form niya. Yung tulad dun dati, no? Then, we have to suppose, no? Kung ano yung mas malaki dito sa dalawang to. Okay? Okay. So, meron tayong underdamped, overdamped, and then critically damped. Alright. Doon sa tatlong yun, yung gusto natin is yung underdamped. Kasi doon tayo magkakaroon ng steady state solutions. Okay, bakit walang steady state solutions yung overdamped and critically damped? Kasi 'di ba magaganon lang sila. So yung t is t approaching infinity, zero na yung mga response mo for the overdamped and critically damped. So gusto mo nag-oscillate yung system over time. So doon tayo interested. Okay, so we have to assume underdamped or this requirement. So omega naught is greater than alpha. So that means that itong term na to mas malaki dito. So ma-overpower ng negative sign. Therefore, this is an imaginary number. And we can call this yung ganito. Okay? Sulat natin siya as ganyan. So si omega d ay just ito. Okay? Okay. So wala namang bago. Ito pa rin naman yung last time, yung chapter 12. Yung second order circuits. Okay? So wala namang bago. So ayan, meron tayong dalawang solution SA and SB for our homogeneous solution. So sulat natin yung homogeneous part na parang tayo malito. So pH is now let's call it AA for this one, and then AB for the other one. Okay, then pwede naman natin isulat pa explicitly. So this is negative alpha plus j omega d times t. And then plus ab e raised to negative alpha minus j omega t times t. Then we can factor out things. So e raised to negative alpha t ay ka ng j omega dt and then plus ab e raised to negative j omega dt. Then I could simplify this into some cosine na lang. Negative alpha t. Magbabago rin yung constant ko. With the appropriate constant, I could write this as cosine. Omega d t plus some phase factor. Okay, so si A prime and V, they are to be determined gamit yung initial conditions which we do not have. Okay? So, ito na talaga siya. Alright, so you have your homogeneous part. So, meron pala akong space dito. Dapat ito pala sinulat. Okay. Anyway. Sige, tapos na tayo sa homogeneous part. Particular naman. For the particular, pwede tayo magpakahirap, no? Pakahirap ka na mag-suppose ka ng ansatz mo na equal sa ansatz mo equal. Let's call that VP equals to some B cosine omega 1t. Kasi yung input natin, di ba? Cosine omega 1t. So mag-assume din tayo ng ganito. Pwedeng ganito. Yung may mahirap na way. Okay? Pwede tayong pakihirap na ganito. Or gawin natin yung last time na ginawa natin. Assume fake drive. Okay, mag-assume tayo na I must be equal to some I naught e raised to S1t. Okay, so ito rin yun. So therefore, kapag palitan natin yung notation para magkamukha sila. Pwede ako mag-assume ng ganito. So may fake drive ako na I tilde. And then para makuha ko yung I of t na legit, I just get the real part of I. Parang yung last time lang. Okay? Last Tuesday. Ay, sorry. May tilde dapat. Okay? So with this, i-assume ko na lang na yung i-assume ko na ansatz would be exponential then. So let me call that VP. And then e raised to S1. Okay, and then to get VP for reals, VP. So that would mean I would get the real part of the... Okay. Okay, so pwede pa akong magpadali ng buhay ko kasi 'di ba naalala nyo na kapag ginamit ko to, magagamit ko yung impedance model. Okay? So syempre, let's take things slow. Gamitin muna natin para hindi naman tayo malito in life. Okay, so kapehin natin tong differential equation natin, try natin plug in yung mga bagay-bagay. So 1 over c di over dt. And then this must be equal to d squared okay, d squared plus pabisado 1 over RC tsaka 1 over LC. dv over dt. Okay? So, try ko muna i-plug in tong fake drive. So, I have I naught over C e raised to S1 S1t. Okay, kasi naka-derivative siya once. And then for this, I have VP times S1 squared, then e raised to S1t, plus here I have VP S1 over RC, tapos dv over dt tuloy, e raised to S1t, and then lastly e raised to S1t VP LC. Okay? Okay, now I can factor out, cancel out. So I have I naught over C S1 VP S1 squared plus VP S1 over RC plus VP over LC. Okay? And then I could multiply C over S1. So C over S1, nangyayari ay I naught na lang sa left hand side, tapos I have CS1 plus VP R plus S VP over LS1. Okay, so this is what I have obtained by inputting or plugging in yung ansatz natin. Okay, similarly, kunin ko tong circuit ko. I replace them with boxes. So this is LS1, R, and this is 1 over C, S1. Tapos anong mangyayari sa input? Kukunin mo lang yung amplitude niya, di ba? Naalala nyo? So this is I0. Okay, and then mag-KCL lang ako. KCL ako dito, so incoming ko would be I0. Then yung mga currents through here ay just V over ZL plus V over ZR plus V over JC. And that is just V LS1 plus V over R. Ito ay VP pala. No? VP kasi particular solution natin. And then this is just VP 1 over CS1. Okay? And tingnan nyo, it's just this. Ito rin yun. Okay? VP over LS1, VP over R, VP over 1 over CS1. So, lilipat lang to sa numerator. Okay? So, ayan. So, meron na tayong pwede mong i-isolate si VP. So, let's do that. So, VP is just I naught divided by 1 over LS1 plus 1 over R plus CS1. Okay? So, ito ay imaginary number. Complex number ito. Complex numbers ito. So, S1 ay J omega 1, di ba? And that's it. That's it. Ito na yung ano ko. Ito na yung makukuha ko na yung particular solution. So, the particular solution is just so yung P tilde ko, P tilde P is just V. Okay? Itong mang kung ano man to. E raised to S1. Okay? And to get the real part of that, it's just the legit na BP. This is just this. And explicitly, we can write this as yung magnitude ng VP tapos times cosine omega 1 T plus the angle of VP. Okay? So may angle si VP guys, di ba? May angle to kasi ito ay complex number. Okay? So pag nasulat mo to in terms of something like this, A plus IB or place A plus JB. Okay? So pwede mo tong i-rearrange, no? Para lahat ng imaginary numbers nasa second term, tapos lahat ng real nandito sa kabila. Then yung magnitude would be yung square root ng A squared plus B squared. And then yung angle would be tangent inverse ng B over A. Okay? So, hindi na natin gagawin kasi haba ng process na yun. Let's just leave it like this. Okay. So, the total solution, add mo lang silang dalawa. So, V of t, the total solution is V of t. Then, I have A prime cosine omega d t plus something t. And then plus this one, VP, magnitude ng VP cosine omega 1 t plus the angle of VP. Okay. So kung makapansin nyo, V of t, the output, yung minimeasurean mo, is a combination of two cosines na hindi parehas ng frequency. Okay, omega d tsaka omega 1. So omega d, this is the damped frequency or yung natural frequency ng circuit mo kapag wala siyang source. Okay? Tapos ito yung dahil sa source. Okay. So, kapag ginraph mo to sa computer, ito yung iba't ibang yung graph. Okay? So, maraming graph to depende sa ipo-plug in mong values ng omega D, omega 1, and so on. Okay? So, kung dito, equal si omega D at si omega 1, sir, question. Okay, question. Sir, akala ko po hindi pwede gamitin yung impedance model kapag kumukuha po ng complete solution. Okay. Bakit tayo gumamit ng impedance model? Kasi sa particular solution natin siya ginamit. Okay? So, itong sa pagkuha mo ng particular solution, pwede kang gumamit ng impedance model. Okay? Kasi ito yung natin, ito yung main event nung topics nung last topic natin. So mahirap yung math. Ayaw natin na mahirap yung math. Okay? So kung may cosine ka na input, pwede kang mag-assume ng Peking drive. Okay? So ito yung Peking drive mo. Tapos with this, pansin mo na yung particular solution mo, magsusuppose ka rin nung na kamukha nung Peking drive mo. So which is this. Okay? And it turns out, itong VI mo, o yung pag-solve mo dito sa constant na ito, F. Dito nanggagaling yung impedance model. Okay? Dito nanggagaling yung impedance model. Nakita natin dito na parang voltage divider lang ito. Okay? Okay na ba? Na ano mo na siya? Nahugot mo na ako saan yung idea. Okay. And, okay, sige. Pansinin nyo rin na yung, balik tayo sa last, pansinin nyo rin, ano yung particular solution dito? Ito, di ba? Tapos kapag in-extend mo yung t to infinity, so yung steady state mo, ano yung matitira? Yung particular solution for this case, no? Particular solution mo, natitira. Tapos sabi ko sa steady state, pwede mo gamitin yung impedance. Okay? So, ayan. Dahil particular solution lang din yan. Okay. Sige, proceed tayo. Okay, so ito yung iba't ibang computer-generated graphs nung circuit natin kung ano yung magiging response niya. Okay, so for yung omega 1 equal sa omega D, ito yung kakalabasan. Tapos kapag si omega 1 is less than the omega D, so mas malakas yung damping frequency nung circuit mo kaysa dun sa frequency nung drive, yung kakalabasan niya. And this one is a much lower omega 1. Okay, so pababa lang na pababa si omega 1 kay omega D. And this one, ladong mas mababa si omega 1 kaysa kay omega D. Similar din dito, ganun lang din. Wala lang, tinatry lang natin kung ano yung itsura ng mga iba't ibang graph, no? And dito sa last case na to, ang maganda, ito ay omega 1. Kabaliktaran naman. Si driving force yung mas malakas. Kung mapapansin mo, para siyang step na cosine. Okay. So now, punta tayo doon sa mas interesting na part. Mas exciting na part. Yung frequency response. Okay, so yung frequency response, tingnan natin yung frequency response nung parallel RLC. So, kung maaalala nyo kanina, di ba, ito yun. Ito yung sinolve natin na VP. Saan yung sinolve natin VP? Ito, okay. So, kunin natin transfer function that is output over input. So, ito yung input mo. Divide mo lang. So, ito yun. Ito yun, okay? Ito yun. Then, plug in na natin yung joke. Ayusin natin ng onte na para mas maganda naman. So, to do that, multiply tayo ng S over C, both side, numerator and denominator. So, ito ay 1 lang to, no? 1 lang yan. So, pwede mong gawin siya anytime. Okay, and then what happens is that, ito magiging S squared, ito magiging S over RC, ito magiging 1 over LC. So, ito yan. Ito. Okay. And then, pag nag-try tayo ng iba't ibang values, let's say ganito yung values, okay? Meron ka 0.5 microhenries, 0.5 microfarads, 4 ohms. Plug in mo dun sa transfer function mo, which results to this. Tapos, ipa-plot mo sa computer, ito yung lalabas. Okay? So, ganyan. So, gusto natin, paano natin natatry ito i-graph intuitively? Paano natin siya magagawa without the aid of computers? Okay. So, balik tayo sa transfer function. So, gawin natin, hiwalayin natin yung real number lang, which is this. And then I have j omega c plus 1 over j omega L. Okay? Okay, and then let me further simplify this by writing down G as 1 over R. Okay, parang hindi lang tayo pagod magsulat ng 1 over R. Palitan na lang natin ng G. Okay. And then, itataas ko to so magiging negative siya. I now have omega C minus 1 over omega L. Okay? Okay. Okay. Pansinin nyo kailan magiging maximum tong maximum tong H natin. So, magiging maximum tong H natin kapag nawala yung imaginary number. Okay? Agree ba kayo dun? Pag nag-zero out to, maximum siya. Okay? Kasi yung magnitude ng dalawang imaginary number. Okay, so, let's say H. Para meron kang H is equal to A plus IB, A minus IB. Yung magnitude ng H, pwede mo siyang kunin as yung magnitude ng numerator. Ay, sorry. Okay, kung naalala nyo pa, no? Pero kung hindi kayo sanay gumamit ng mga ganitong simplification, okay lang na naman. Pwede mo naman to i-transform into something na hindi na rational. Anyway, pero kung rational siya, pwede mo siyang kunin yung magnitude ng numerator, divide mo sa magnitude ng denominator. Okay, so kung kunin mo to, kung kukunin natin yung H na magnitude, sorry. Okay, H magnitude dito sa case natin, this would mean that magnitude ng 1 ay 1. G plus J omega C minus omega 1 over omega L. Okay? Okay. So kapag pag hindi to 0, yung magnitude ng denominator would look like something like this. Some constant C. Okay? And this is greater than G. Okay? Pag zinero out mo naman to, matitira ay G squared lang. So this is equal to G. Therefore, yung pinakamaliit na value na pwedeng kunin ni denominator ay yung kung saan mag-zero out tong dalawang terms dito. Okay? And then kapag minimum value na yung denominator, ay na yung largest number na pwede mo ma-obtain sa isang rational number. Tama ba? Tama ba? Okay? Okay. So, yan. So, gusto natin makuha yung maximum ng H. So, let's do that. I-zero out natin to. So, mag-zero out to kapag omega C is omega C minus omega C minus 1 over omega equals 0. Okay, so lipat mo lang sa kabila. Ito yung lalabas. Therefore, divide mo by C, you get omega equal sa ano pala, omega squared pala ito. Omega squared equal sa 1 over LC. So therefore, omega is 1 over LC. Okay? So you obtain the maximum transfer function or minimum transfer function at this point. Okay? Sa LC. So 1 over LC square root. Okay? And dinatawag natin to na resonance frequency. Okay? And mapapansin nyo si resonance frequency ay yung omega naught lang. Okay? Kaya siya pinangalan ng ganyan. Okay? Kung magtataka kayo from last 4 chapters, bakit ba pinipilit na maging ganito yung itsura ng ano? Ba't ba natin pinipilit maging ganito yung itsura ng mga bagay-bagay? Okay? So may sense siya. May sense siya kung bakit siya yan. So ayan. Si omega naught yung resonance frequency mo. And ang nangyayari doon at your resonance frequency, makikita natin mamaya mas magandang use niya, yung circuit, para siyang pure capacitor. Nagka-cancel yung effect ng inductor and capacitor. Okay? Okay. So at this circuit, tingnan naman natin yung balikan natin tong equation na to. So let's put it here. So I have 1 G plus J omega C minus omega L. Ay, 1 over omega L pala. Sorry. Ben. Okay, so at low frequency, ano mangyayari? At low frequency, the omega approaching 0, ang mangyayari ay this term approaches infinity, this term approaches 0. Okay, so ito ay magiging infinity, ma-overpower niya si G. Therefore, what is left is 1 over negative J times 1 over omega L, or in simple terms, pwede natin iakyat si J towards the top kasi papalitan mo lang yung sign niya. Tapos ito, akit talaga yung 1 over omega L, akit talaga yan. Have this. Okay? So, at low frequency, para siyang inductor lang. Inductor lang yung nag-e-effect. And then, so bakit natin ginagawa to? Ba't natin tinitignan yung omega approaching 0? Ba't natin ginagawa yung omega approaching infinity? Tinatry natin mag-graph na. Para mas maintindihan natin. So, meron na tayong yung isa, nakuha natin yung maximum. And then, itingnan natin kung ano yung itsura niya at malapit sa 0, tsaka yung infinity. Okay. Kapag approaching infinity naman, this term becomes 0 and j omega c becomes infinity. Tapos ma-overpower niya si g. So, ang matitira na lang ay 1 over j omega c. Okay? So, para siyang capacitor lang at high frequencies. And then, yung phase makukuha na natin dito. So, tangent inverse ng omega L over 0, that's 90. And then, tangent 1 over omega C divided by 0 kasi walang real part. Tapos, ito ay negative. So, may negative sign ako. So, that's negative 90 degrees. Okay, so 90 plus 90 sa low frequency. Then at infinity, negative 90 yung phase. Okay, so meron tayong sa logarithmic scale, no? Ito ay linear. Tapos, ito rin, linear din naman sila parehas. Pero ito ay pababa, ito ay pataas. So, meron kang pataas na linya, meron kang pataas na asymptote, meron kang pababang asymptote, and then you have a maximum here na value. Okay? Okay, so in-scale na tong numerator mo. Ay, yung numerator totally. Yung y-axis mo. Kasi ito ay, ano yung maximum natin? 1 over g, di ba? Yung maximum natin ay 1 over g. Kapag nag-zero out ito. So, h max is just 1 over g. And yung g natin ay 1 over r. So, therefore, yung h max ay r lang. Okay? So, yan. Ito yung maximum mo. So, tapos ito rin yung sa phase natin. Nakita natin na meron tayong asymptote na tawag dito. Plus 90 tapos minus 90. And then, pansinin din natin na kapag nasa omega naught tayo or dun sa resonant frequency, ano mangyayari? Yung H natin is just real part lang. Real part lang to. So, zero yung angle. So, therefore, we have that point. Okay? So, meron tayong point dito. So, we have 3 points. Enough for us to build a hula ng graph. Okay? So, ayan. Ito yung hula ng graph natin for the parallel RLC. Pansin nyo, sundan nyo lang yung asymptote, tapos akit ka dun sa maximum point mo, tapos baba ka. Tapos sa phase, ganun din. Kailangan mo daanan si omega naught, 0. Kasi at that point, real part lang yung matitira sa transfer function mo. Okay, so we have that. So ano itsura ng legit na graph? Dito yun, di ba? So ito yung itsura ng legit na graph. Ito yung computer-generated graph. Malayo pa yung drawing natin, so kailangan pa natin i-refine. Okay, so yan. So, in short, pwede mong gawin tong 3 steps na to para makuha mo yung plots ng magnitude tsaka yung phase with respect to the frequency. Okay? So, yan. So, pupunta ka sa low frequency, pupunta ka sa high frequency, then punta ka sa resonant frequency. Low, high, resonant frequency. Now, let's try to determine kung gaano ba kalawak tong part dito. Paano ba natin ito mag-graph ng mas maayos? Okay, so let's go back to dun sa transfer function natin for the circuit. Okay, so ang magandang gawin, let's write this down again as G plus J omega C minus 1 over omega. Okay. So what if itong term na to is just G? Okay. G plus J, G. Okay. And then, kapag kinuha ko yung magnitude nito, ang makukuha ko ay magnitude niyan. And this is just easy. 1 over g. Tapos square root ng 1 plus 1. So this is just 1 over square root of 2 g. And yung 1 over g, alam natin siya na ayun yung max. So let's write it down. Ito siya, di ba? Okay, so therefore, it's nice na makukuha natin yung term, yung value na yun. So tinatawag natin siyang 0.707 yung square root ng 2. Sorry. H max. Okay? So, ayan. So, gusto natin maging G itong term na to. Maging G yung term na to. And actually, you can also include the other one. Kung naging negative to, same pa rin makukuha mo. Okay? Kasi ito ay squared. And kahit negative squared mo yan, ganun pa rin. Okay? So, therefore, meron tayong dalawang omega kung saan makukuha natin na itong whole term na ito ay magiging G. Okay? Okay. So, let's do that. So, dapat itong term na to, yung omega C minus 1 over omega L, dapat equal kay G. So, therefore, let's write that down explicitly. G must be equal to plus or minus yung omega C minus 1 over omega L. Okay, so pinangalanan natin siyang omega 0.707 para ka-partner niya to. Okay, so you can achieve this at omega 0.7. And we need to find this frequency. Okay? Okay, so here we have So, ayusin lang natin to. Ito ay G equals sa plus minus omega 707 C minus 1 over omega 707 L. Okay, tapos multiply ka ng omega, both sides. You have G omega 707 tapos plus minus omega 7 squared C 1 over L. And then rearrange things. Divide by C. Okay. Ito yung makukuha mo essentially. Okay. Pwede mo naman ilipat yung plus or minus by multiplying plus and minus din. Okay. So, yan. Ito na yung makukuha mong quadratic equation. Then, you find that the quadratic equation would result to this quadratic formula. Okay? So, negative b. So, plus and minus pa rin. Babaliktad pero doesn't matter. Negative b. Tapos, plus and minus, square root ng b squared. So, sulat natin. No? So, omega. Baka nalilito yung iba. So, negative b over c plus or minus. This plus or minus then 4g g over 2c. Ay, g over c. Negative b squared lang pala. No? b squared. Tapos minus 4ac. A mo ay 1. Tapos c mo ito. Tapos negative. So, magpa-plus lang to. 4 over LC. Then all over 2 times A, which is 1. Okay. And then, simplify mo lang. Mapasok natin itong 2 dito sa loob ng square root. So, magiging square siya dun sa loob. So, I have G over 2C plus or minus 1 over 2 squared plus 4 divided by 2 squared. So, 1 na lang. Okay. Tapos, pwede ko ipasok itong 2 squared sa loob. Ito yung kakalabasan. Okay, ito na yung kakalabasan. And then, gusto natin malaman kung alin sa roots tatanggapin natin. No? So, meron tayong plus and minus for the roots. Okay. So, omega is a real number, real and positive number. So, omega is real and positive. So, measurable si omega. Kaya, kailangan real and positive siya. Mahirap magkaroon ng negative ng omega kasi wala siyang sense, negative frequency. Okay, so we want this whole thing to be positive. Now, pansinin nyo, this term is always greater than, kung di mo i-mind to, no? Kung di mo i-mind yung 1 over LC, ito ay magiging square root ng G over 2C lang. So, ka-cancel nung square tsaka square root. So, this is just G over 2C. Okay, and then plus or minus G over 2C. Okay, so it can be 0 or it can be negative kung positive si G over 2C. Okay, so itong whole term na to, equal siya or lagi siya mas malaki kay G over 2C. Tama ba? Therefore, kailangan lang natin kunin yung positive nito, positive nung root. Okay? Kasi kailangan mas malaki lagi itong whole term na ito kaysa dito. Kapag negative kinuha natin, surely magne-negative ito. Surely. So we don't want that. Okay? Kuha ba yan? Kuha ba yan? So therefore, we have two values for omega. Omega 0.77. 0.707. So that would be yung, kunin lang natin yung plus, tapos yung plus and minus. Okay? And then, gaano kalaki to? Gaano kalaki? Di ba kasi meron kang, pag nag-graph tayo, meron kang, this is omega. Okay? So, meron kang dalawang values for omega 0.7. So, ibig sabihin, kapag nasa h.707 ka, tapos ito yung h max. Okay? Ibig sabihin, at dalawang points, dun yung omega 0.77 mo. Okay? And gusto nang tingnan natin kung gaano kalawak tong part na to. And to do that, minus mo lang yung mas malaki kasi mas maliit. Ito yung mas malaki, definitely. Minus mo dito. And you'd see that, ginawa mo yun, ang lalabas ay G over 2C minus G over 2C. So, magiging plus na lang siya, diba? So, that's G over C. Okay, so, syempre, magkakancel ng dalawa. So, meron tayong tinatawag na bandwidth. Yan. So, G over C is the bandwidth. Makes sense naman, ito ay bandwidth. Width to ng band. Okay. So, G over C is just 1 over RC. So, plug in na lang natin ulit si G, no? Para parang tayo malito. So, si G ay, ulitin lang, 1 over R. Bakit natin ginawa to? Kasi gusto natin, tamad tayo magsulat. So, para hindi hassle magsulat, ilagay natin si G is equal to 1 over R. And reverting back, we have the bandwidth, which is 1 over RC. And kung maalala nyo, 1 over RC is just yung 2A. So, yung 2A is just your bandwidth. Okay, kaya siya, bakit tayo nagpapakahirap na isulat yung mga bagay-bagay? Something like this. Saan na yun? Nawala. Yan. So, yung 2 alpha is just your bandwidth. This is your resonance frequency. Nice. So, going back, nakakahilo ba? Okay, so ito yung bandwidth natin, 2 alpha. And okay, so using that, madodrawing na natin yung gamit yung dalawang extra points na to, mas maganda na yung drawing natin. Okay, so meron na tayong 5 point of interest, no? So dalawa, plus yung 3 kanina. Dalawang asymptote, tapos yung isang maximum. So 5 points. So yan, therefore, kuwari mag-drawing tayo. Okay, so resonance frequency, nandun sa maximum, tapos drawing ka ng 0.707, nandun yung dalawang omega. And then, dalawang asymptote. Ay, drawing mo na ng maayos. So the bandwidth is this. Okay. So, ayan. Pansinin nyo at some cases, yung symmetry nung G over 2C, yung bandwidth, hindi siya nakasenter sa omega. Okay? Kasi, balikan natin yung formula. Saan siya symmetric? Saan yung gitna nitong dalawang to? Which, ito yun, di ba? Itong term na to. So, from this term, nagdagdag ka, tapos nagbawas ka by the same amount. So, therefore, ito yung gitna nila. On some cases, hindi equal yung omega naught. Okay, ay mag-load. Hindi equal yung omega naught dun sa factor na yun. Okay, so ito tinatawag siyang center frequency. Okay, and this one is, alam naman natin yung omega naught is the resonant frequency. Okay, so now let's go back dun sa quality factor natin. So yung quality factor can now be defined as resonance frequency divided by bandwidth. Okay, bandwidth. So for our case, yung quality factor natin is omega naught over G over C. Kasi yung bandwidth natin, siba G over C siya. Okay? Ayan. So, wag yung pansinin mo na to. Ito yung definition from the last time na pinag-usapan natin yung quality factor. So, recall lang ano yung quality factor. So, mas mataas na quality factor, mas matagal mag-oscillate yung circuit mo. Okay? Okay. So, yung definition na ganon, nasa time domain siya. So, with respect to time. No? So, mas marami kang oscillations per time. So, ano ibig sabihin ng quality factor kapag in terms na sa frequency? Okay. Mapansin nyo dito, yung nakalagay dyan, yung mataas na Q, mas maganda yung peak ng frequency. Okay? Or trough. May trough naman. Pabaliktad naman siya. Okay? So, mababang Q, pangit yung peak mo. Okay? So, therefore, kung defined as this yung Q mo, therefore, yung bandwidth can be obtained as this. Okay? So, resonance frequency divided by Q. Kung given ka ng quality factor. Okay. So, let's go back doon sa 0.707 na frequency. So, we have this, di ba? From this, let's write this down as 0.707 G over 2C plus minus plus G over 2C squared. Then, sulat ko siya as omega naught squared. Okay? Omega naught squared. Kasi si omega naught si omega, di ba, 1 over square root ng LC. So, omega naught squared yung 1 over LC. Then, I try to factor that out. That's G over 2C. So, pag pinactor out ko siya, omega na lang siya, omega naught. Then, I would have 1 plus 1 na lang to kasi pinactor out mo si omega naught squared. Then the second term, or the first term here, is divided by omega naught squared. So we have g squared over 4 omega naught squared c squared. Okay, but looking back, kung ano yung Q, Q is just omega naught c over g. So, ayan, mapansin nyo, dito omega naught c over g. So this is just 1. So this is just 1 over 4q squared. Okay, and then for q by standards, q engineering greater than 5, ito ay sobrang liit. So q 5 squared, 25 times 4, 100. 1 plus 100 tapos square root pa nun. So negligible yon. So this is just equal to plus minus g over 2c ng omega naught. Ayan. Kaya mapapansin natin at high Q, so Q greater than 5, yung center frequency equal na siya sa resonance frequency. Okay? Such as this example. Okay. Nice, di ba? Okay. So now, balik tayo sa drawing natin kanina. So ito na siya. So meron tayong asymptotes dito. Then nagkaroon tayo ng dalawang extra points. So yung 0.707R or yung maximum na H in general. So meron kang dalawang points doon. So kumpitin mo kung ano yung si omega 0.707. So these points yun. Okay, now you can draw it nicely. Okay. So, yung sa face naman, para sa face, saan mapupunta yung 0.07? 07. Kung maalala niyo, di ba, ito siya? Equals siya sa 1 over g plus jg. So, ibig sabihin, pag kinuha mo yung angle nito, ang lalabas dyan, g over g. Okay, so this is 1, and yung tangent inverse ng 1 or arctangent ng 1 ay 45 degrees. So nangyayari yung 0.07, hassle naman bigkasin, 0.707 frequency at the 45 degree angle or 45 degree na phase. Okay, so ayan. So compute mo lang si bandwidth, ito siya. Okay. Tapos, ayan, plot mo lang sila na mas madali. Mas maganda na yung graph natin. Ayan. So, ito yung itsura ng different Qs. Kapag high Q, mataas yung quality factor, mas maganda yung peak mo. Mas mataas, mas matulis. So, low Q, ayan. Hindi siya matulis. And then for the phase, anong effect ng Q? Mas abrupt yung change kapag mataas yung quality factor, kapag mababa yung slope nung yung slope nung pag shift from 90 degree to negative 90. Okay? Okay. So now you might be tempted na laging ganun yung equation, no? So it's different. It's different. So let's try another equation. So let's try another circuit. So series RLC naman, mapansin nyo magbabago lahat yung equation mo dito. Pero, ayun. Let's try to get the, let's see na lang. Tingnan natin yung frequency response nito. Okay, so punta tayo sa impedance model. And yung I would be So the potential Vi is just I times Z total. Okay? So yung Z total would be, nakatatlong series lang naman, so add mo lang sila lahat. So I, R, tapos plus LS, plus 1 over SC. Okay, so ito na yung ano mo, ito na yung equations mo. Tapos yung output mo ay I, input mo ay VI. Therefore, yung equation mo dapat ito. Okay, so ayan. Then, transfer function yung mahalaga sa atin, so divide natin by the input yung output. Okay? So, lagi nagbabago yung transfer function, guys, ha? Depende kung ano yung output na kukunin mo. Okay? Okay. Hindi siya voltage to voltage lang. Pwede rin siyang input to voltage, pwede rin voltage to input, ay, voltage to current, sorry. Anyway, ayan. So, ito yung itsura. Ba't may VI dito? So, mali na naman yung libro. Ayan. Okay, and then inayos nyo lang by multiplying S over L. Okay, S over L would be pag nag-multiply tayo ng S over L, numerator and denominator, yung ito ay magiging S squared, ito ay magiging 1 over LC, ito ay magiging S over L, SR over L. Okay, so si resonant frequency, same pa rin. So ito yun. So omega naught. Tapos bandwidth mo magbabago, R over 2L, ay R over L. Okay, and then quality factor would change. So quality factor is resonance frequency over bandwidth. So omega naught over this part. So omega L over R. Okay? Okay. Now, okay. So ito na yung ano, hindi na natin siya i-solve. May example sa libro syempre. You need to try those. Ang amazing dito is that kapag kumabit ka sa iba't ibang elements mo, iba't ibang filter makukuha mo. Okay? So, dapat parang inisip nyo na kanina, oh, filter pala itong mga ito. Okay? Filter siya. Okay, so kunwari meron tayong series RLC. Pwede natin kunin yung VR, pwede natin kunin yung VL, pwede natin kunin yung VC, and pwede natin kunin yung combination ng dalawa. Okay? So, syempre, pwede mo rin kunin yung sa VR and VL. Hindi ko alam kung ano lalabas. Pero, ayun. Ito yung apat na kukunin natin for this example. So, for this example, quote unquote, for this part, yung gagamiting values ay ito. And then, yung omega naught, pag kinumpute mo siya, so 1 over square root ng LC, ito yung lalabas. Alpha mo would be coming from this, R over L. And then, teka, double check ko lang kung same yung values nung ano. Values nung alpha. Okay, sabi na parang may mali. Hindi, tama lang pala. Okay, tama lang pala. Okay, so yung bandwidth dito, kasi minsan di ba sinusulat siya as 2 alpha? Okay, ito pa rin yung 2 alpha. Okay, so alpha is equal to R over 2L. Okay, so magkakancel lang yung 2, so R over L pa rin. Okay, nalito lang ako for a while. Pero ayun, so R over L. Okay, so ito yung mga important values lang. Okay, so ayun. So let's try measuring the voltage across the resistor. Okay, so paano magkuha ng voltage? Nakuha na natin yung I, di ba? Nakuha na natin yung I for this case. So yung I ay this part. So with this current, para makuha lang yung voltage sa R, multiply mo lang yung R. Para makuha sa voltage dito, multiply mo lang LS. Kapag gusto mo kunin yung voltage dito, kunin mo lang yung, multiply mo lang yung 1 over SC. Okay, so for the resistor, I times R lang siya. So VR is equal to this part. Okay? Okay, so transfer function would be dividing VI with this. So VR over VI is equal to this part. So SR over L, tapos yung square, yung quadratic equation sa baba. Okay. So by inspection, tingnan mo yung behavior niya sa maliit na frequency, tapos tingnan mo sa malaking frequency. Okay? So maliit na frequency is low, tapos high. Okay, so sa low part, ilalapit mo na sa 0 yung mga S. So therefore, matitira lang SR over L, tapos omega naught squared. Which is a linear, pag ganun. Tapos sa high frequency, so para siyang R over L, tapos para siyang S squared sa baba. So 1 over S ito. 1 over S. So pag ganun. Okay. And then mapansin mo, makukuha mo yung maximum, which is yung 1 as a maximum. Okay, paano mo makukuha yun? S equal to J omega. And pansinin mo, kapag omega naught nilagay mo dyan, yung resonant frequency, mapansin mo, S squared is just, mali. S naught. S naught squared would be J omega naught squared. J omega naught squared. So this is negative omega naught squared. Okay, so H max is just J omega naught R over L, and this is negative omega naught squared plus omega naught squared plus 2 alpha S or J omega naught. Okay, and then this cancels out. 2 alpha is just R over L, so cancels out, 1. Okay, so you have your maximum, tapos you have these behaviors. Okay, so therefore, yung graph mo would look like this. Okay, and then from here, makikita mo na this is positive 90. Kasi this is imaginary number lang siya. Tapos dito, ganun din, imaginary number nga lang din to. Tapos, ang pinagkaiba lang is nasa denominator yung s. So, pag tinaas mo siya, magiging negative dahil ito ay imaginary number. So, therefore, 90 sa low frequency, tapos 90 degree, negative 90 sa high frequency. Okay, tapos resonant frequency yung 10 raised to 6. Okay. Okay. Hindi natin siya iyan. So, pwede mo bang kunin yung extra points sa graph mo, yung omega 0.7 para mas mag-graph siya ng mas maayos. Okay. So, yung bandwidth for this case is, ayan. So, yung bandwidth na lang kunin mo para makuha yung itong part na to. So, omega naught lang siya divided by Q. So, omega naught divided by Q. Alright. So, this part is a bandpass filter. Tinatawag natin bandpass filter kasi kung mapansin ninyo, yung maximum na output is found at doon sa ditong part lang. Okay, so, at this parts, ito lang yung makukuha mong frequency. Okay? Okay. So, anong silbi nitong bandpass filter? Ang silbi niyan ay pag gusto mong ayaw mo ng other inputs, okay? So, ayaw mo matanggap yung other So, input to output. So, yung output sa side mo na. So, input everything that's coming from the outside. So, yung input mo, kuwari, range siya ng frequencies. Gusto mo lang kunin yung certain frequency na gusto mo. Gagawa ka ng ganitong circuit, no? So, may bandpass filter ka. Tapos, i-adjust mo na lang tong resonant frequency mo para makuha yung gusto mong desired mong frequency. Then, para mas maganda pa lalo, tataasan mo yung quality factor para tumulis siya. Para isang frequency lang talaga yung maaabot mo. Isang frequency lang na makukuha mo. Okay, so sa mga radyo natin, ganun yung idea behind it. So meron kang resistor, inductor, and capacitor. Tapos babaguhin mo lang yung value ng LNC. Okay? So paano mo babaguhin yung value ng LNC? So yung L, di ba, inductor yun? Inductor siya. Tapos saan gawa yung inductor? Sa coils ng wire, di ba? So kapag inikot mo yung mga sinuunang radyo, no? Kapag inikot mo yung knob, dumadami yung coils doon sa inductor mo. Okay? So natataas at nabababa mo yung L. Okay? So magagalaw mo yung resonant frequency. So kung wari gusto mong pumunta siya sa Wish 1075, so yung Wish 1075 ay 107.5. 107.5 megahertz. Personal, hindi ko alam kung kilohertz or megahertz. Pero ang point ay, ayan yung frequency niya. Lilipat mo sa omega in terms of radians. So this is 2 pi f. Okay. Tapos, gusto mong iset yung system mo sa omega naught equal to this amount sa 2 pi f. Okay, so, i-adjust mo yung LNC such that nakatutok siya sa 107.5. Okay? So, lahat ng binobroadcast sa ere, lahat yan, iba't ibang frequency yan, yung lalabas lang sa output mo would be yung dinesign mo. Okay? So, yung dinesign mo ay makukuha mo lang yung stasyon ng Wish. Okay? Okay. So, ganun yung mga sinaunang radyo. Okay. So, balik tayo sa mga low-pass filter. Alam na natin to from last time. So, yung low-pass filter, ideal siya sa dito. sa capacitor for this case. Okay, so ayun, para makuha lang yung voltage sa capacitor, si I mo multiplyan mo lang ng impedance nung capacitor. Okay, so current, multiply mo ng impedance ng capacitor, which is 1 over SC. So you have this, and then the transfer function is dividing the output, VC, divided by input, VI. So you have 1 over LC, and then the quadratic equation at the denominator. So again, kunin mo lang yung low, yung high. Okay. So low frequencies, constant lang. Okay? So constant. Therefore, ganun yung graph. For the high frequencies, this is gawin natin para hindi tayo mahirapan sa life ay factor 1 per s squared, tapos ito ay 1 plus 1 over s plus 1 over s squared. So, ginawa ko na lang silang constant kasi approximate ko naman sa... hindi. Wala pa rin sense pala. Ang point ay at high frequencies, this is tsura niya ay something that's proportional to 1 over s or 1 over s squared. Pero ang point ay pababa lang din naman yun. Okay? Okay. So, ayan. Tapos, at the resonant frequency, constant value lang din yung nasa resonant frequency and hindi siya yung, well, maximum pa rin naman nata siya. So, try natin plugging in the resonant frequency. So, this is 1 over LC. Or sulat ko na lang yung numerator in terms of omega naught squared. Omega naught squared, tapos minus omega naught squared, plus omega naught squared, plus 2 alpha j omega naught squared. Ay, omega naught. Okay. This cancels out, and you have omega naught, tapos 2 alpha, tapos j. Okay. Ayan. So, ito ay constant. So, plug in mo lang siya dyan. Ayun yung peak niya, which is around this value. Okay. So, yung resonant frequency dito, para siya yung corner frequency. Okay. And then, sa phase naman, since yung low frequency natin, constant lang, ibig sabihin, zero yung angle mo, yung phase mo. So start siya with 0, tapos at high frequencies, nasa denominator yung tawag dito. Denominator yung imaginary number. So therefore, magne-negative siya. Tapos, tangent inverse ng some number divided by 0. Okay? So this is negative 90. Tapos negative kasi siya. Yan. Oh, bakit mo negative 180 to? Hindi. May real part siya. Okay, sorry. May real part siya. So, kapag sige, hindi na natin papakompute naman ito. So, ayan. Sige, ang interesting na part dito is that kapag sinulat natin siya as something like this, okay, balik lang tayo dito sa part na to. Sinulat lang natin to as omega naught squared. Ayan. Tapos, at the resonant frequency, ito yung lalabas. Okay, ito na yung kinompute natin actually. Omega naught over 2 alpha. Okay, so, tinanggal lang yung negative sign kasi kukunin mo na naman yung magnitude. Ang point ay, this is the quality factor, Q. And kung mapapansin nyo, yung quality factor can range from 0 to some number, di ba? Kunyari, yung quality factor mo ay 1,000. 1,000. Okay, tapos yung input mo ay 1 volt lang. Yung voltage mo sa capacitor, lumalagpas siya. Okay, lumalagpas siya sa 1 volt. Okay, dahil nagre-resonate sa kanya yung ibang tawag dito, nagre-resonate sa kanya yung ibang waves nung galing sa inductors. Okay, kaya siya lumalaki ng ganyan. Okay, so parang counterintuitive siya ngayon, pero imagine niyo, paano ba kayo gumagalaw sa isang duyan? Diba? So, sa duyan, onting effort lang nilalagay mo kada back and forth mo, di ba? Kasabayan mo lang yung wave ng unti-unti mong puwersa. I-shift mo lang yung wave, yung weight mo by some amount. Tapos lalakas na ng lalakas yung duyan. Okay, so ganito lang din yung idea doon, kaya siya lumalakas ng ganito. Okay, and then nangyayari din to sa mga physical natin. Well, physical naman ito. Sa mga buildings natin, sa bridges, buildings, ganyan. So, yung mga bridges natin, they have their natural frequency na tinatawag. So, doon, natural frequency, kapag nasabayan yun ng external drive or winds, ganyan, earthquakes, na yung frequency ay katulad doon sa natural frequency nung building mo, nung bridge mo, may resonance na nangyayari. Okay? At delikado yun. So masisira yung building kapag nangyari na yung driving force mo ay same frequency doon sa natural frequency. So magkakaroon ng ng resonance. Okay? So sa mga building sa Japan, merong computer controlled na counterweight doon sa loob ng buildings. So meron silang mga tonelalang bakal doon sa loob ng building na computer controlled. So, ibig sabihin lang nun, gagawin nung bakal na yun. So, meron kang may metal na malaking ganyan. So, magra-rock siya back and forth. Kukontrahin niya yung wave na ginagawa ng external force. Okay? So, kukontrahin niya yung frequency nito para mawala yung frequency dun sa loob ng building. Okay? So, yung building mo, magsasway siya, ika-counteract niya yung sway nung external force. Okay? Kasi pag nagsabay yung sway nung external, yung driving force, doon sa sway nung building, magre-resonate yung dalawang waves, yung dalawang frequency nung external and then yung building. Tapos nasisira siya. So, sa YouTube, makakanood kayo ng mga ganun nasisirang tulay dahil hinahangin. Okay. So, nice. Wala lang. Ay, hindi ko pala nalagay yung picture dito. Okay. So, yung picture dito, for high Q. Pansin nyo, di ba parang may onting, dito, may parang onting peak dito. So, tumataas siya actually ng paganto. So, para siya nagiging, notch pa rin. Notch tuloy, bandpass filter pa rin na combined with a low pass filter. Okay? So, ayan. Okay, and then, pag nag-measure naman tayo sa inductor, so VL, again, I times yung impedance lang, we have this Okay, and then transfer function as usual. And then low frequencies. Low frequencies, linear lang siya. Or mag-zero out. Okay. So low frequency, S squared, maliit. S squared, maliit. S maliit. Okay. So, ito ay magmumukhang ganito. Or not exactly naman, di nung kailangan i-solve mo. Kailangan nyo lang makita yung itsura ng ano. Itsura nung mga bagay-bagay. High frequency magiging constant kasi S squared over S squared lang ito. So, magiging ganun. So, pag kinombine mo, ganito siya. Combine mo, ganito siya. Okay. So, 180 na naman yung maximum kasi ito ay sige. Basahin nyo sa libro kung bakit. Okay. Lastly, for this case, nangyayari din yung ganitong ano, nangyayari din yung ganitong may resonance din sa nangyayari doon sa inductor mo. So, pwede siyang gumano. More than one yung ano, transfer function. Okay, so and lastly, notch filter or band stop filter. Measure natin yung voltage doon sa both ng inductor and capacitor. Okay, so yung impedance nung combined capacitor and inductor is this. Okay, and then, ayan, ito na yung transfer function. You have S squared plus 1 over LC. And mapapansin mo na kapag nasa omega equal omega naught, yung S squared ay magiging negative omega naught squared. And this is also omega naught squared. So magzi-zero out yung transfer function mo. Okay, so meron kang trough. Meron kang, yeah, pag ganun siya. And then, sa low frequency, ano ba itsura? Sa low frequency, this is just 1. So, zero out mo lang to, zero out mo, zero out mo. Okay, so, omega naught squared over omega naught squared, so that's just 1. For high frequency, this is also 1 kasi S squared over S squared lang. 1, so therefore, constants na pa ganun. Tapos, yung phase nito sa low frequency and high frequency, 0. 0. Tapos, ang problema doon sa resonance frequency niya, sa resonance frequency niya, 0 yung transfer function mo. Ibig sabihin, may dalawang points ka. Okay, tangent inverse ng 0 can be plus 90. Joke. Can be sige, plug in nga natin. Hindi, 0 talaga to. Tama. Yung real part kasi 0, di ba? Kasi 0 na to. So, undefined itong tangent inverse mo. Magiging 90 degrees siya plus or minus. So, nag-exist siya at both 90 degrees and negative 90. So, ayan. Dalawang points yung tatamaan mo at the resonant frequency. Okay. So, para makuha tong graph na to, kunin mo lang yung 0.7 0.07, 0.707. Hindi na natin siya gagawin. So, para malaman mo, bakit hindi pa ganun? Ba't hindi pa ganyan? So, malalaman mo siya gamit itong 0.707. So, makikita mo at the 45-degree angle, nasaan siya? Positive ba siya or negative? So, okay, anyway, ayun. Basahin nyo na lang yung isa, stored energy in a resonance circuit. Tapos, we're done. Okay. So, yung notch filter naman, para may maiwan kang, may ayaw ka na frequency na ma-output. So, at this point, 0 yung output mo, di ba? 0 yung output over input mo. So, may frequency ka ma-filter out kung ayaw mo siya marinig. Okay, ginagamit to usually sa mga power outlets kapag yung mga charger natin. So para maiwasan yung 60 Hz na 60 Hz na frequency, gumagawa sila ng band stop filter. Para yung output sa charger mo wala ng 60 Hz. However, vulnerable ka sa mga low frequency and high frequency sudden inputs na. Ano lang. Nice to know. Any questions, guys? Any questions? Okay, sige, tapos na yung lecture natin. So, magpo-post na lang ako ng mga announcements regarding this exam schedules, etc. Okay, so preferably, dapat tapos na tayo before June 1. Okay, so tapos na tayo dapat before June 1 para makapag-focus na kayo sa proposal nyo. Okay? And then, in tentative na, gusto nyo ba mag-exam on 25? Okay, so may choices kayo ng exam na 25, 28, tsaka 28, 31. So message nyo ako kung ano nyo gusto nyo. Malami kaming deadline sa 25. O di wag 25, okay lang din naman sa akin. So 28, tsaka 31. Ay hindi, sige ano na lang, 28 tsaka 4. Okay ba sa inyo yun? 28 tsaka 4. Kasi pag 31 naman, syempre nagpe-prepare kayo for sa June 1, di ba? Parang tanga naman. Parang ewan. May defense pa ba ng 4? Di ba 1 to 3 lang? Depende pala nung nag-announce na ba ng schedule. Nag-announce na ba ng schedule? Kasi ang usapan ay 1 to 3 or 2 to 4. Okay. So, ayun. Sige. Pero definitely third exam 28. Okay. 28 na yung third exam. Okay, okay. So, yung finals na lang kung sino gusto mag-finals. Okay. Included po ba ang chapter 11 sa third exam? Ang chapter 11 ay, ano ba yung chapter 11? Hindi ko na i-include yung energy and power, digital circuits. Pero baka magtanong ako ng energy sa resonance. So, basahin mo. Okay, questions? Gagamit po ba ng inductor sa ibang remaining lab experiment? Hindi na. Sir, maaari po bang makita yung solutions ng exam 2? Ah, magpo-post ako kung magdi-discuss ako ng exam 2 solutions. Okay, guys, medyo dehado yung dehado yung scores nyo sa exam 1 and 2. Okay, may mga hindi sumagot ng mga madadaling tanong na naman. Hindi ko alam bakit ninyo sinasagutan yung mga tanong. Ample naman yung time given to you. Okay, wag mag-overthink sa exam. Tapos sa mga magpo-finals, bumawi. So yung finals, full topics. So lahat ng topics. Okay, syempre yung di pa rin naman makakalimutan yung mga first topics. And then may pinost ako na prob set, guys, no. May pinost na ako ng mga prob set, so you try those. Extend, marami kayong kailangan gawin sa 25. 25 ba yung nilagay kong date sa prob set? Hindi ko alam maalala. Or 28 ba? Teka. Let me check. Ah, 28 naman pala. Okay. So, 28 yung deadline ng mga prob set. Okay, so goods. Sir, maaari po ba makahingi ng ID or clue sa final experiment? Sa final experiment, kailangan nyo yung idea nung lahat ng bagay. So, kung di nyo pa rin na-gets yung mga diode, ganyan, you might want to study them. Sir, kailan po mapapublish sa Canvas yung exam 2 scores? Ano material na kailangan sa final experiment? Ipopost ko. Ipopost ko yung guidelines this weekend. Kailan po mapapublish yung exam 2 scores? Next week. Bago mag third exam. So, para malaman nyo kung kung kailangan nyo mag-finals. Okay? Optional yung finals, no? Optional yung finals. Kasi, isipin nyo rin, worth it ba yung effort na gagawin nyo sa finals? Lahat po ba diretso na finals? Oo, diretso na final project. Okay, sir, yung mga topics lang po na lumabas sa 3 exams, yun lang din yung lalabas, syempre. Yes. Lalabas sa finals exam. Any more questions? Okay. Kung wala, mo-check ako attendance. Okay. Okay, sige. Smile and wave, boys and girls. Ay, wait. Okay, sige. Okay na. Galingan sa galingan sa final exam, guys. Kailangan nyo mabawi yung mga questions na naguluhan kayo sa mga lalo na sa first exam. So yung mga bagay na dapat devening. So dapat na sa inyo yun. Ah, dapat intuitive na sa inyo. Kung alin yung mga parallel, kung alin yung mga series. Okay? So, kailangan mabawi yung first exam, guys. And syempre, kailangan pumasa. Sige, sige. Kung wala nang tanong or kung meron pa, i-send sa Canvas or sa email. Okay. Thank you, guys. Good luck, good luck. So magpo-post na lang ako kung magdi-discuss ako ng exam solutions. Tapos hindi recorded yun, as usual. Okay? Okay, okay. So sige, bye class. Have a nice weekend.